Alright, this question 8 lana si discuss ama electric circuits. Check out the description box for more questions on what pendulile for this November 2022 question paper. Alright. Now, larabati the diagram below, each cell has a voltage of 1.5 volts. Use the diagram to answer the questions that follow. 8.1, we have 8.1, but you see, told the reading for voltmeter 1. Voltmeter 1, this reading la. Sinama cells ayingaki, but each cell has a voltage of 1.5. Sinama cells ayingaki, let's count. 1, 2, 3, 4, 5. A cell uyibona ngani? Uyibona ngale line elikhulu ne line elincane. Line elikhulu, line elincane. So sina 5 yama cells la. So voltmeter 1 uzoba equal to 5 cells times 1.5, the voltage for each cell. What is that? It's 7.5. So answer A to 7.5. 8.2, calculate the following: the total resistance of the circuit. Grade 11 usazoyithola electricity, and it's almost the same as the one year laga grade 10. Grade 12 usazoyithola electricity nakhona, but ka grade 12 so ukhuluma nga something called electromotive force yama battery, right? So ninani ankhulumi ngayo. So electricity sasekhona grade 11, grade 12. So make sure ukuthi you understand the topic le on our electric circuits. 8.2, calculate the following. 8.2.1, the total resistance of the circuit. So in a parallel connection as well as this resistor which is connected in series with this parallel connection. So the first thing is so calculate the resistance, the total resistance for the parallel connection. Then sithola the total resistance by adding this resistance yala with the total yala ngoba they are connected in series. So asenze so for total resistance for parallel connection, sizoti 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is, so I say to R1 give about 6, so it's 1 over 6 plus 1 over 4 plus 1 over 3, 1 over R parallel, 1 over 6, 1 over 4 plus 1 over 3. Answer with 3 over 4. 3 over 4, but this is not our final answer, so we answer A to 9. R parallel is equal to 4 over 3. You just flip the fraction yako so that uzothola R parallel as the subject of your formula. So 4 divided by 3, it's 1,3333333. Let's take it to 2 decimal places or 3 decimal places. 333. Yes, 333. Then R total, the total resistance for the circuit is R parallel plus 2,67. So answer A to 1,333 plus 2,67. Answer plus 2,67. Answer A to about 4. About 4. Yeah, 4 ohms. Now answer it. Okay. So this is the total resistance. Ammeter A ammeter A, so sifuna the current ke manje, the current. This current this current represents the current for the whole circuit. This A2 will represent the current eflowa la ku 6 ohm resistor kuphela. So sithina sifuna ubani u A1, current ka A1. So in order ukuthi senze lokho sidinga 2 yezinto la. Okay, ngishaya space ithi ngizombhala la. This was 8.2.1. Mina sengicalculate to 8.2.2. So in order to calculate to A1, the current flowing through the whole circuit, ngidinga uV total ngenayi nang 7.5 V, 7.5. The voltage for the whole circuit 7.5. Ngifuna I, so apply Ohm's law. Ngifuna I resistance, the total resistance I do have. So udinga the total voltage for the circuit, udinga the total resistance for the circuit. You also need what? Since I calculate the current for the whole circuit, so udinga the total and the total, right? So applying Ohm's law, I is equal to V over R. Answer, what's the voltage? To 7.5 divided by 4. Answer it to 1. 7.5 divided by 4. 1.88 in 2 decimal places. It's 1.88 amperes. Now answer it again. This one is voltmeter reading number 2. Voltmeter reading number 2. Alright, nginasi space la. Do I have space? Alright, that's one. 8.2.3. Sifuna V2 ke now. Sifuna reading ka voltmeter 2. Voltmeter 2. Alright, so V2, I have a resistance R. I also have a current. This current in a series connection, a current iba constant. Yes, a current iba njani iba constant. The only thing iba divided is voltage. So a voltage for this resistor angeke be the same as the voltage for this parallel connection. But the current a flow la, the current a flow along the parallel connection will be the same. Go parallel connection again. Go parallel connection, current gets divided. Current ya divide. Current a flow la, ngeke fana ne current a flow la, ngeke fana ne current a flow la. Yes, but if voltages will remain the same. So lana, that's why I'm saying with the current ya la, a current a flow la kule resistor is about the same as the total current for the circuit. Let's see we calculate. Yes, so ngifuna u V2 ku A. Okay, V2 uzoba equal to current times resistance. I'm manipulating the formula le ka Ohm's law, equal to what's the current? 1.88 times resistance 2.67. 1.88 times 2.67. Answer 5.02. 5.02 volts. Alright, for the last question, Lago 8.3, but it determine the magnitude of the charge that flows through A1. That flows through A1. Okay, I think eraser la. Alright. Slide 8.3. So now, uma uya ku formula sheet yakho, there's this formula le. Q over T. On your formula sheet, you should get a formula efananale. Current equal to Q over T. Since ngifuna the charge that flows through ammeter 1, sifuna ukwazi ukuthi kuflow ama charges angakanani, kuflow ama charges angakanani in 6 minutes, kule ammeter yethu le. So since basiphe isikhathi 6 minutes, which by the way komele we change it to seconds. We only do calculations ngani ngama seconds, so it's 360 seconds. I also have a current flow akubani ku A1 ubani 1,88. so I just need to substitute I substitute ubani T, then I can find Q, the charge flowing through ammeter A1. 1,88 equal to Q divided by time, 360 divided by 1, we cross multiply, Q over equal to 1 times Q, it's Q, 1,88 times 360. So it's 1,88 times 360, ithola 676.8. 8 coulomb. So our charges are flowayo at this point or the ammeter angaga. Now your final answer to lagu question 8. Thanks for tuning in, guys. Thanks for watching. Check out the description box for more recordings and for the question paper. So for now, ngizothi bye bye. But ungakhohlwa nokulike nokushare nokusubscribe nangabe new to this channel. So for now, asibonana on the next video. Bye bye.